greatest and best song in the world.
Hello, students. This is Mr. Ezra. Today we're going to be talking about polynomial functions a little bit more, specifically symmetry in these types of functions, even symmetry, odd symmetry, and neither symmetry. So let's get started. So main focus today is what's the difference between an even and odd function. And I don't want to confuse you. We do talk about even functions sometimes when we're talking about the degree of the function, whether or not the degree is even or the degree is odd. But today we're talking about something a little bit different. Today we're talking about the symmetry that the function makes when it's graphed, and this function can be classified as either even, odd. So algebraically, if we're trying to decide if a function is even, odd, or neither, a function is even or it has even symmetry if all of the exponents of the variable are even. So you have to look at each term, each part, and if every single exponent is even, then your function is going to be even. It's going to have even symmetry. You can probably guess the next one is a function is odd, or it has odd symmetry if all of the exponents of the variable are odd. Then, of course, the function is going to be neither even nor odd, or it's going to have neither even nor odd symmetry if the exponents are a mixture of even and odd exponents. I want you to be cautious as you're doing this. Every constant that you come across, remember a constant is a term in a polynomial function that does not have a variable. There's no x, there's no letter, it's just the number. Well, all constants really have an x to the 0 power attached to them. And x to the 0 power is the same thing as 1. Also want to remind you that 0 is an even number. 1 is odd, 2 is even, 3 is odd, 4 is even. So 0 is going to be classified as even. You can think of even as being evenly divisible by 2. And 0 is evenly divisible by 2. 0 divided by 2 is 0. It divides evenly. Graphically, we have to actually look at the graph and look for the symmetry. A function is going to be even if the graph reflects across the y-axis. That's the vertical axis. That means if you fold it along the vertical axis, hot dog style, the left side of your function and the right side of your function, the left and right side of the graph would match up perfectly. We would say that the function has odd symmetry if the graph has 180-degree rotational symmetry about the origin. This means that if you kind of like rotated your paper and turned it upside down, it would look exactly the same as it did before you rotated it 180 degrees. These types of functions, when they are polynomial functions, must go through the origin. If it doesn't go through the origin, then there's no way for it to be odd. It cannot have odd symmetry if it does not go through the origin. So let's look at several examples. Our first example, would you say that this is even, odd, or neither? Well, look at the y-axis here, this vertical axis. If we fold it hot dog style there, the right side and the left side would match up perfectly, making this an even function. It has even symmetry. What about this guy right here? Well, if I fold it along the y-axis, it does not line up perfectly. You can see that this what's on the right side does not have a mirror on the left side. But if I were to put a dot in the middle and rotate it around this dot, you see that this right side of the graph, once rotated 180 degrees, would match up with the left side. So it does have that 180-degree rotational symmetry. You also see the function here, f of x equals x to the third minus x. Well, anytime there's an x without an exponent, there's understood to be a 1. So notice that both 3 and 1 are odd, and that this function has rotational symmetry here. So we would say that it is odd. It has odd symmetry. Example 3. Well, certainly I don't have the hot dog fold, so it's not even. It looks like it might have odd symmetry, but it does not go through the origin. Because it does not go through the origin, then this would be an example of neither even nor odd. All right, let's try example 4. Would you say that this function is even, odd, or neither? Here we have algebraically x to the second power plus 1. Now 1 is a constant. What do you remember about constants? Boom. Remember that anytime there's a constant, it's like there's an x to the 0, and 0 is considered to be even. Since 2 is even and 0 is even, we would say that this function has even symmetry. We don't have to look at the graph because we know that both exponents are even. The graph would have that even symmetry if we were to graph it. Example 5 and 6 here, 2x to the 4th minus 3. 3 is a constant, so boom. Remember that x to the 0 is there. We're not going to see it. It's never going to be written in there, but you have to remember that it is there. And since it is there, 4 is an exponent, 0 is an exponent. They're both even, making this function even. Now, on example 6, f of x equals x to the 3rd plus x. There is already an x here. Okay, that's not a constant term, it's an x term. But there's no exponent. What is that exponent understood to be? Well, if there's an x with no exponent, the exponent's understood to be 1. 1 is an odd number. 3 is an odd number. So we would say that example 6 has odd symmetry. 3 more examples. Why don't you pause the video really quickly and try each of these and see if you can guess what they are. All right, so hopefully you've had a chance to take a guess at these, a crack at these. Our first example, f of x equals negative x to the 3rd here. What did you put for that? Hopefully you put odd. Since 3 is an odd exponent, we would say that the function has odd symmetry. The same thing is true for your second example, also an exponent of 3, also odd. We're in the third one on the screen here, we have x squared plus 4. 4 is constant, which means it's got x to the 0. And 2 and 0 are both even, makes this function even. All right, we've got some graphs. Why don't you pause the video and see if you can guess whether these have even or odd or neither symmetry. All right, well, hopefully you've had a chance to take a crack at these. First, the one on the left, we have got a hot dog fold here. It looks like it's going to fold perfectly over. That's even symmetry. And the one on the right, if we put a dot in the middle at the origin and rotate, and notice that it goes through the origin, and we rotate it 180 degrees, we're going to see odd symmetry there, that it lines up with that rotational symmetry. Here's 3 more for you to try. All right, the one on the left, what do you think? Good job. Even is correct. All right, the one in the middle, what do you think? Mwah, mwah. This one is neither. It does not go through the origin. It does not have the symmetry across the y-axis. It doesn't rotate 180 degrees around the origin, so it's neither. But the third one is odd. It does rotate 180 degrees perfectly and line up with itself. All right, try these 3. All right, the one on the left, what did you get? You're right, 3 and 2 are not both even, not both odd, making this neither. They must be the same for it to be even or odd. The one in the middle, you've got 3 and an invisible 1 there. Those are both odd, so hopefully you put odd. And for the one on the right, we've got 3, an understood 1, and an x to the 0. Well, 3 and 1 are odd, but 0 is even. So this is going to be an example of neither. And I'll be honest, after the last few years of putting a few of these on tests, this is the kind of problem that students miss the most often, where they've got a few odd and they forget that this last one is even, that anytime you have a constant, it's going to have an x to the 0. So be cautious when you're working through these. It's going to seem super easy. It's not difficult, but there are lots of students who in the past have made mistakes with these types of problems just by forgetting something like the constant always has an even exponent, x to the 0. Well, that is it for today. I hope this brief introduction to even symmetry, odd symmetry, or neither even nor odd symmetry made sense to you and that you're able to fly through the practice. I will see you in class.